Good morning, ma'am. My name is Chandra Maheshwari, CSC branch, second year, A section. Today my topic is recurrence relations. Let us see the next. To get the final solution of a problem, there are four steps. First, define the problem. Next, determine the problem. Then next, find the characteristic roots, and then we can get the final solution. First, establish the variables and the overall goal. Next, utilize initial conditions to solve the system of equations. Next, solve the characteristic equation for roots R1 and R2. And next, derive the closed form expression for an. Next, understanding the problem. The second order relation. First, recurrence type, relation type. We are analyzing a second order linear homogeneous recurrence relation with constant coefficients an plus 2 plus b an plus 1 plus c an is equals to 0, where n greater than or equals to 0. Next, the unknowns. The primary goal is to determine the two unknown constants b and c using the known sequence terms. The initial conditions are a0 is equals to 0, a1 is equals to 1, a2 is equals to 4, and a3 is equals to 37. Final objective. Once b and c are found, we can derive the explicit closed form formula for an. Prerequisite: the characteristic equation. The general method for solving linear homogeneous recurrence relations involves setting up the characteristic equation. First, solve the roots, form equation, substitute, and then start. First, find R using quadratic formula. Next, simplify to R2 plus B, R plus C is equals to 0. And let AN is equals to Rn. Give the recurrence relation. Next step 1. Form the characteristic equation. Substitution. Assume the solution is of the form an is equals to Rn and substitute it into original recurrence relation Rn plus 2 plus Brn plus 1 plus Crn is equals to 0. Next, simplification. Divide the entire equation by Rn, assuming R by n equation 0. This reduces the order of the equation. R power n plus 2 by R power n plus b R power n plus 1 by R 0 to n plus c R power n by R power n is equals to R square plus br plus c is equals to 0. Next, solving the constants b and c. We substitute the given initial conditions into the original recurrence relation to establish a system of linear equations of b and c. Next, step 3, solving the characteristic equation. Now that we have determined that b is equals to minus 4 and c is equals to minus 21, we can solve the characteristic equation and find the roots r1 and r2. R square minus 4r minus 21 is equals to 0. This is the characteristic equation. Next, substitute b and c into the quadratic formula. Next, calculate the value under the square root. 16 minus 4 into 1 minus 21 is equals to 100. Then, as we know that square root of 100 is equals to 10, final roots are, we should determine the R1 and R2. Thank you.